And so our next speaker is going to be Christine Hartzell, talking to us about the JPL Lunar Dust Mitigation Science Definition Team, Dust Mitigation via Electrostatic Lofting.
Hi, yes, I'm presenting on behalf of the JPL Lunar Dust Science Definition Team. Can we go to the next slide? So this is a team funded by the NASA Division of Biological and Physical Sciences and STMD to identify payloads for a multi-user facility on the lunar surface to conduct dust plasma science and test dust remediation technologies. So we're focused on plasma-related remediation technologies. Basically, these are technologies that would induce electrostatic lofting. Additionally, if we want to consider testing these dust remediation technologies on the lunar surface, we require some infrastructure. So we need a method to assess the efficacy of these technologies and also a method to reliably load the same amount of dust onto test articles. Next slide. All right, so we have identified a couple of lofting-based remediation technologies. And by electrostatic lofting, I'm talking about this idea that if we have an electrostatic force that's on dust particles that is larger than the forces holding particles to the surface, these particles can sort of hop off of the surface. So remediation technologies in this category either amplify charge or the electric field or both. The most well-known of these remediation technologies is this KSC electrodynamic dust shield, which we heard about earlier today. These are some images on the right from a paper written about that technology. And basically there's a traveling wave that travels through a series of electrodes and it causes these dust particles to exhibit little hops across the surface and clear the surfaces. Another technology option is a dust attractor plate. This is an ongoing task funded by the SMD's Picasso program, where a strongly biased plate basically attracts dust particles, causing them to detach from the surface and again, hop off the surface. And finally, a third option would be plasma beam impingement, where you have a high energy electron beam or just the exhaust, for example, of your plasma propulsion system. There's impinging on the surface.
Christine, you have 1 minute remaining.
Thanks, causing charge amplification and or removal via drag. Let's go to the next slide. Okay, so if we want to test efficacy of removal technologies on the surface, we need some infrastructure. Our idea is that you would have a series of sample coupons and take images of those coupons after loading dust onto the surface, then apply your remediation technology and then take a before and after sort of photo to see how much dust was cleared off the surface. So we have an idea of a series of sieves and funnels that would cause this dust to deposit on a series of coupons. Let's go to the next slide. So this is just my contact information. Happy to take any questions about the work of this science definition team. Thanks.
Okay, awesome. Well, thank you so much,